All right, guys, today we are going to go over percent error and percent yield. These two things are ways of indicating how well a lab went. So oftentimes after we perform a lab and we collect our product, we want to see how close we got to the answer that we should have. All right, guys, today we're going to go over percent error and percent yield. These are two ways of analyzing how well a lab went. So in a lab, we often collect product. And when we collect product, we want to see how much product we collected and is that amount what we should have collected. So we want to compare and see how well we did. There are two ways to do this. The first way is with percent yield. When we are finding percent yield, we take our actual value over our theoretical value times 100. Now, it's important to know what those terms mean. When we talk about our actual yield, this is what we actually collected in the lab when we ran it. So how much product did we collect? The theoretical value is what we calculated from our math or our stoichiometry. This is telling us how much we would have collected if everything went absolutely perfect in the lab. So when we are analyzing our percent yield, it is essentially telling us what percent of the product we recovered. So ideally, we would like to collect 100% of the product. In reality, you're never really going to be able to collect 100% because no matter how careful you are, there are still spills or leaks within your setup and your apparatus. So we want to get as close to 100 as we can, but in all reality, you're not going to get 100%. The second way that we can analyze how well the lab went is through percent error. Percent error is going to use those same theoretical and actual values. Again, theoretical is the amount that you calculated that you should get through your stoichiometry. The actual value, again, is what you actually collect in the lab. So when we're doing percent error, what we do is take our theoretical minus our actual. So we want to know how far off were we from the correct answer, essentially. Then we're going to divide that by our theoretical value and multiply by 100 to make it a percent. Ideally, if everything goes absolutely perfect, our theoretical and actual value in a lab would be the same, which means that our percent error would be 0. If everything goes absolutely perfect, you would want to find 0% error. So let's look at some problems to see how we can use our percent yield and percent error for error analysis. All right, in our first problem, we have aluminum reacting with copper 2 chloride to give us copper and aluminum chloride as our products. I already have the balanced equation written, and that is your first starting place. Now, the question asks how many grams of copper are produced when 2 grams of aluminum reacts with copper 2 chloride. All right, so this is just a normal stoichiometry problem right now. We want to determine what two substances we care about the amount of. It is asking me about grams of copper, so I'm going to find copper in the balanced equation. And it asks me about grams, or tells me about grams of aluminum. So I'm going to find just aluminum in the balanced equation. Now, the aluminum and the copper in this reaction will react in a 3:2 ratio, but that ratio only works when I'm in moles. When I go to start the problem, I want to start with the number that's given to me. So I am given 2 grams of aluminum. From those 2 grams of aluminum, I want to figure out how many grams of copper I am going to produce. So I can't use the mole ratio until I'm in the unit of moles. Since I'm in grams, I'm going to go to the periodic table and I am going to add up. I'm going to go to the periodic table and I'm going to find the molar mass of aluminum, which is 26.98. And I'm going to put the grams on the bottom so that my units cancel out. Now if I stop the problem, I have moles of aluminum. As soon as I have moles, I am ready to use the mole ratio. So I'm going to add another step, and my mole ratio is 3 to 2. Remember that we need to make sure that moles of aluminum are on the bottom of the fraction so that our units and our substance cancel out. The coefficient tells me that for every 3 moles of aluminum, I am going to produce 2 moles of copper. If I were to stop the problem right now, I have moles of copper, but notice that the problem is asking me for grams of copper, so I'm going to go one step further and get my grams of copper. When I go to the periodic table, I find that there are 63.55 grams in 1 mole of copper. I chose to put the moles on the bottom so my units canceled, and I am now ready to solve. Your best bet for solving this is to multiply everything on the top together, multiply everything on the bottom together, and divide your top by your bottom. When I do that, I get 3.15 grams of copper. That is the amount of copper that I expect to produce if everything goes perfectly in the reaction. That means that this value that I just obtained here is my theoretical yield. All right, so whenever you are doing dimensional analysis, the amount of product that you should produce through your stoichiometry problem is going to give you your theoretical yield, or the amount that you should produce if everything goes perfect. But if we go to the next part of this problem, it says that a scientist collects 2.99 grams of copper when they actually run the experiment. So since I'm not running the lab myself, this actual amount would have to be given to me in the problem. So our end goal here is to find the percent yield. So I'm going to write my percent yield equation. My percent yield is equal to my actual divided by my theoretical times 100. One thing you want to make sure when you're using these equations is that the unit and the substance on your actual and theoretical yield should be the same every time. So if my actual amount collected was 2.99 grams of copper, I need to make sure that my theoretical value, the amount I calculate, is also grams of copper. They must be the same unit and the same substance. We then multiply by 100 in order to get a percent. When I do this, I end up with 94.9% yield. What that tells me is that when I ran the experiment, I collected 94.9% of what I should have gotten. All right, let's look at another problem. This time, everything is given to me all in one piece. I don't have 2 separate parts to the problem. So notice I have a balanced equation, and underneath the equation, it tells me that 8.9 grams of NaCl is collected when a chemist reacts 12 grams of KCl with Na2SO4. I am trying to find the percent error. So again, I'm going to start these problems the same way every time. I'm going to identify the 2 substances that I care about the amount of, and I'm going to find them in the balanced equation. The first substance is KCl, so I'm going to find that in the balanced equation. And the second substance that I care about the amount of is sodium chloride. Always make sure you have the end point in mind. This problem ultimately is asking us to find percent error. That means percent error is our ultimate endpoint. I am going to write the equation for percent error. And remember that it is the absolute value of our theoretical minus our actual divided by our theoretical times 100. I always want to start with the end in mind. So the end of this problem is asking me ultimately to find the percent error. The percent error can be found by taking the absolute value of our theoretical minus our actual over our theoretical times 100. All right, when we are talking about percent error or percent yield, it's important to remember that those are pertaining to our product. How much product did we collect? So I know that the product here is NaCl. Everything that goes into this reaction is going to need to pertain to the product NaCl. I'm going to find the percent error in calculating my amount of product collected. If I know that 8.9 grams of NaCl was collected, that is the actual amount that they got in the lab. I am going to erase my actual value here, and I am going to plug in 8.90 grams. Again, this is pertaining to the NaCl. That means that my theoretical yield needs to be in grams of NaCl as well. So if I can find grams of NaCl, I can solve this problem. Now, I know how much reactant I'm starting with, and I'm starting with 12 grams of KCl. So now I can use my stoichiometry to get from grams of KCl to grams of NaCl. I'm going to start the problem with the amount that's given, 12 grams of KCl. And I ultimately would like to use the 2 to 2 mole ratio from the coefficients in my balanced equation, but I can't use that value until I'm in the unit of moles. I'm currently in grams, so I'm first going to change my grams into moles by going to the periodic table and adding up 1K and 1Cl. When I do that, I find that there are 74.55 grams of KCl in 1 mole of KCl. I chose to put the grams on the bottom so they canceled out. Now I'm in moles of KCl. I'm ready to use my mole ratio. For every 2 moles of KCl, I know in this reaction I'm going to produce 2 moles of NaCl. My moles of KCl cancel out with my moles of KCl. Remember, my end goal is to get grams of NaCl so that I can plug it into my theoretical value here. Now I'm going to go to the periodic table. I'm going to add up 1 Na and 1 Cl, and when I do that, I get 58.44 grams of NaCl. Now I have grams of NaCl, and that was my end goal, so I am ready to solve. When I solve, I'm going to multiply across the top, then multiply across the bottom, and divide my top by my bottom. When I do that, I find that I get 9.41 grams of NaCl. Remember that the amount that I calculate in the stoichiometry problem is always telling me the theoretical amount that I would get if everything in the lab went perfect. Now that I have my theoretical value, I'm ready to plug that in for the T. All right, now that I have both theoretical and actual, I am ready to solve. I'm going to take 9.41 minus 8.90. That's a positive number, but if it were a negative number, I would just take the absolute value or make that a positive value. And then I'm going to divide it by 9.41, multiply by 100 to make it a percent. When I do that, I end up with When I do that, I end up with 5.4% error. One quick and easy way to double check yourself is that your percent error and your percent yield should always add up to 100%, assuming that your yield is not over 100%. So that's a nice way that you can double check yourself if you're solving for yield and error in the same problem. I hope that cleared up any questions you had on how to calculate percent error and yield. Thanks for watching, and don't forget to check out my other videos.